Let's look at how to use the voltmeter to measure a voltage. The first step is to set zero reading to 0. So we are going to look at this voltmeter. Right now it's slightly off, so we're going to turn it, see, so that it's pointing at 0 right there. Now let's see how to read the voltmeter. It's very important that you know which range you're using. So look at the bottom switch. Right now it is at 5 volts. So right here. That means we are using the range as 5 volts or the scale of 5 volts. What does this mean? This means if the needle is at the full span, if the needle is right there, the reading will be 5 volts. So if you look at all these scales, we should be reading is the second line on the scale. It reads 0, 1, 2, 3, 4, 5 volts. Okay. So once you know that, you can decide the uncertainty and take the reading. How do you decide the uncertainty? You can see that between 0 and 1 volts, there are 10 divisions. Therefore, the smallest division is 0.1 volts. Take half of the smallest division, so we can say our uncertainty is 0.05 volts. So now let's read the voltmeter. You can see that this reading is between 1 and 2 volts. So we can count is 1, 1.2, 1.3, 1.4. It is at 1.43 volts. So we got our reading, which is 1.43 plus minus 0.05 volts. Because this volt is less than 2.5 volts, we can actually use a smaller, more sensitive scale. So we are going to switch to 2.5 volts and try to read this voltage again. This time the full span is 2.5 volts. And if you look at these 3 scales, they are 10, 5, and 25. So we don't really have a 2.5 volt reading there. The best we can do is use the bottom line. That's from 0 to 25. However, we want to read them as this, divided by 10. So 0, 0.5, 1.0, 1.5, 2.0, and 2.5 right there, which is the full span. So keeping that in mind, let's first decide the uncertainty. There are 10 divisions between 0 and 0.5 volts. So one smallest division is 0.05 volts. Half of the smallest division will therefore be 0.025 volts. Let's just round it to 0.03 volts as our uncertainty. You can see the uncertainty is smaller. That's because we are using a more sensitive scale. We can't go to the next scale because this voltage is more than 1 volt, and we can no longer use 1 volt, which is the next scale. 2.5 is the best that we can use. Now we can take this reading. It's more than 1.0, less than 1.5. So let's read it. So each small tick is 0.05, each big one is 0.1. So it's 1.0, 1.1, 1.2, 1.3. It's right at 1.4 volts. Because our uncertainty is 0.03 and it's right at the division line, so this reading is in fact 1.40 plus minus 0.03 volts. Now let's look at how to use the ammeter to measure current. First, you should zero your ammeter. The method is the same as the voltmeter. The connection of the ammeter is very different from the voltmeter, but the reading, the principle of reading the ammeter is similar. First, you decide what range you're using, what scale you're using. And right now we are using 5 amps. That means we are using the second row of the labels, which reads 0, 1, 2, 3, 4, 5, amps. So let's decide the uncertainty and the reading. Between 0 and 1 amp, there are 10 divisions. So one small division is 0.1 amp. Half of the smallest division is 0.05 amps. That is our uncertainty. To take this reading, okay, we're going to read it's 0 here, 1 there. So each division is 0.1. We are reading 0.1, 0.2, 0.3. It's almost at 0.4, but just a little bit smaller than 0.4. So I can take this reading as 0.39 amps plus minus 0.05 amps. The currents we measure in this lab are all very small, so we are going to use 1 amp scale. When we use the 1 amp scale, we need to use the top line of the scales. So the top line from 0 to 10, but divide the number by 10. The way we are going to read is 0, 0.2, 0.4, 0.6, 0.8, and 1.0. So to estimate the uncertainty, there are 10 divisions between 0 and 0.2. Which means each division is 0.02 amps. Half of the smallest division or the uncertainty is 0.01 amp. Now we take this reading. It is more than 0.1, less than 0.2 amps. And each division is 0.02, so it's 0.1, 0.12, 0.14. It's more than 0.16, but less than 0.18 amps. Since our uncertainty is 0.01 amps, that has only 2 decimal places. So our reading will also only have 2 decimal places. If it's closer to 0.16, we are going to read 0.16. If it's closer to 0.17, we are going to read 0.17. We're not going to read 0.165. So right now, this reading is closer to the middle of 0.16 and 0.18. So I'm going to take this reading at 0.17 plus minus 0.01 amps.